Alright, today we're going to look at section 8.7 is simplifying radical expressions. And so to start out with, there's two ways to look at radical expressions. The one way is looking at it in exponent form, so 2 to the 4/5. And the other way is radical form. It would be the 5th root of 2 to the 4th. These two things here are the same. Actually, I think if I remember, yep, so these are equivalent. And so if we look at 2 to the 4/5, the number on the bottom, this is what root we're talking about, and the number on top is the power. So just jot down that these two things are equivalent, and this will help us later on today. Alright, so let's look at some vocab before we get started here. The radicand is the stuff underneath the square root symbol, or this is called a radical symbol. So the radicand is the stuff underneath the radical symbol. And in this example, it's 3x to the 7th. The index, this is what root we're talking about. So this is the 4th root in this example. So the index is 4 here. Okay, so make sure we have these, we understand these before we move on the rest of the video. So radicand, stuff under the root, and the index is whatever root you're taking. So let's look at an example here. We're going to multiply these two. So the index is 3 on these, therefore we can multiply these two radical symbols. The only way you can multiply them is if the index is the same. So let's multiply them. We take the radicand, 3x to the 4th over y squared, and times that by 9x to the 4th times y to the 5th. And so we get 3 times 9 is 27. So we take the 3rd root of 27. And then x to the 4th times x to the 4th is x to the 8th. And then y to the 5th over y squared, that's going to end up giving us y to the 3rd. Okay, so this is those two radical expressions multiplied together. And then we can simplify this if possible. So the 3rd root of 27, what number times itself 3 times will give you 27? That's 3, so we can pull the 3 out. And then x to the 8th, I'm going to think about that as x to the 6th times x squared. And we'll just drop that y to the 3rd there. And so what I'm looking for is powers that are divisible by 3 evenly. So x to the 6th, if we take the 3rd root of that, oops, that's the 3rd root. If we take the 3rd root of x to the 6th, that's x squared. You basically just do this number divided by the index. So we'd have 3x squared, and then y to the 3rd, the 3rd root of that is just y. And then what's left over underneath the 3rd root is x squared. And so this is our final answer. Once we simplified it and pulled everything out that we could, we get 3x squared, y, and then the 3rd root of x squared. Okay, so let's look at a couple more examples. Here is another one, but this one is the square root symbol. And so if the index is not there, we've seen these a lot in our life, this means the index is really just 2. So it's square root. And if it's the power of 1/2, this is also square root. This is, we convert this into a radical thing. So it's square root, and then 4x y squared to the 1st power. So it's to the 1st power, it's just itself. So this is really the square root of 4x y squared times the square root of 8x to the 3rd y to the 5th. Okay, so we multiply these two things. 4 times 8 is 32. X times x to the 3rd is x to the 4th. And y squared times y to the 5th is y to the 7th. And so we can take the square root of any of these things. We'll do that to simplify it. So 32, I'm actually going to break this up into the square root of 16 times the square root of 2. And then we'll write all the other stuff in there. Actually, I take that back. We'll put x to the 4th. And then I want numbers that are divisible by 2 for our power. So I'm going to go y to the 6th and y to the 1st. So now if we simplify this, square root of 16, that's going to be 4. And the square root of x to the 4th, that's going to be x squared. And the square root of y to the 6th is y to the 3rd. So what's left over is the square root of 2 and the square root of y to the 1st. So after we simplify this, our answer is 4x squared y to the 3rd and then the square root of 2y to the 1st. Alright, so that's it for this one. And then let's look at the next example. If we're dividing these radical expressions, it's pretty much the same thing, just what you would think. So this 1/2 power, I'm going to rewrite this thing on top here. This would be 8 and then the square root of 54 x to the 5th all over 4 square root 3x to the 3rd. So when we're dividing radical expressions, the index has to be the same, and here it is. This is index is 2, and the index is 2. And so then we can divide the stuff underneath the square root. So I'm going to start. I notice that 8 over 4, that reduces down to just 2 over 1. And I'm actually going to rewrite this stuff with just one big square root symbol. And so on top it'd be 54 x to the 5th. And on bottom we'd have 3x to the 3rd. Okay, so we get 2 square root, and then 54 divided by 3 is 18. And x to the 5th divided by x to the 3rd is x squared. So if we simplify this, the square root of 18, I want to think of that as the square root of 9 times the square root of 2, and then the square root of x squared. So square root of 9, that's 3, so 2 times 3 is 6. Square root of x squared is x, and the square root of 2 we just leave. We can't simplify that any further. So our final answer is 6x root 2. Okay, and then one last one for today. If we're adding radical expressions, you can only add like terms. Just like when we're adding, 3x plus 4. So like a little side example. Well, I think I have a little note here. So you can only add or subtract radical expressions if the radicand and index are the same. So what that means is, as long as, I'll scratch that, you can only add or subtract radical expressions. Wait, time out. Yeah, so this is right. You can only add or subtract radical expressions if the radicand and index are the same. So the index is 2 on both of these. So what we can do is we can add the 6 and negative 7. So 6 plus negative 7 is negative 1. But then we can't add these yet because root 12 and root 75 don't have the same radicand. So plus root 12 plus root 75. So what we got to do is simplify these because square root of 12 and square root of 75 are not simplified yet. So I'm going to rewrite these. And square root of 12 I would break into square root of 4, square root of 3. And square root of 75 is square root 25, square root 3. And so this ends up being 2 root 3 plus 5 root 3. And so when we combine these like terms, we get, for the final answer, negative 1 plus 2 root 3 plus 5 root 3 is 7 root 3. So if the number under the square root is not the same, you have to try to simplify it, and if you can get it to be the same, then you can add those radical expressions. Okay, so that's it for the notes. The assignment is on page 532. It is these problems. And let's have this done for tomorrow, please. Have a wonderful day.